Hello and Happy New Year to you. Welcome to 2025, which I have now learned is a very special number. It is no less, I found out that it was 80, a multiple, that's the word, a multiple of 81. I now know it is the secret times the secret squared, 45 squared. We are living in glorious times. 2025 is the absolute power of the secret, it's brilliant that it's the first day of a new year. It's brilliant that it's the first day of a new month, because that means we have released a new patron reward. On our Patreon site you can go and try Blobs' The Hobbit, his follow-up to Lord of the Rings. It is an absolute mind-blowing chain of genius. So there are 19 puzzles. You have to solve them each in turn to get information for the next one, and it is a wonderful quest. Really something you can spend your time on and be very glad you did. Do check out our Patreon. There's loads of other stuff there. And I'm going to do a puzzle by Blobs today to celebrate. And there's another reason I'm doing a Galaxies puzzle today, which I will tell you about in a moment. Firstly, don't forget that we have loads of apps available as well, including Fog of War, our latest one, which is fabulous. We've got some merchandise, and we've got Sven's Sudoku pad on the links under the video. However, the first puzzle is to Galactic Census 2. So Blobs has come up with a rule called Galactic Census, and this is a puzzle in which we divide the grid into galaxies. Now, why is that special at the moment? Because skywatchers are waiting, hoping for T Corona Borealis to flare up again. So this is a little bit of the sky. I mean, do look it up. It's in or just beside the Corona Borealis constellation. And that literally means crown of the south, but you can see it in the northern hemisphere. And I believe that what causes it is two dwarf stars orbiting around each other, one of which is pretty much dead and the other is gradually dying. But it is believed that every 80 years or so, they reach a point where one sucks the energy from the other and glows extra bright for a period of about 2 or 3 Earth days before fading again back to its normal, almost invisibility. And, you know, that needs to be commemorated. I don't know if anybody has seen it yet this time round, but it's about now that it's due. It was last seen in, what now? Can I remember when? 1946, I believe. And before that, in 1866. So we're expecting it now. And when I say we, I don't mean me, I mean astronomers. There was a very good story in the British newspapers of a 14-year-old boy who was the first, possibly only person to actually observe the phenomenon last time in 1946, and is still alive, aged 95 now, hoping to see it again, which is brilliant. Anyway, I will say that maybe doing a puzzle on galaxies is a bit misleading, because Corona Borealis, like pretty much everything you can see in the night sky, is in our own galaxy. We can't actually see other galaxies except possibly the Magellanic Clouds or 1 or 2 other bits and bobs that very dimly could be seen by the naked eye on a perfect night. But basically we can't see other galaxies from here without super telescopes. So maybe it's a little fictional to be dividing a grid into galaxies, but we're going to do it today anyway, because we haven't done a galaxy puzzle for a while. Now, what are the rules? I'm going to go through the rules of Galactic Census 2 by Blobs. Normal Sudoku rules apply, 1 to 9 in every row, every column, and every 3 by 3 box. We have to divide the whole grid into galaxies, which are orthogonally connected groups of cells that have 180-degree rotational symmetry about their centers, which are marked with a small dot. So this would qualify, for instance, as an 8-cell galaxy centered on a dot. It's got 180-degree rotational symmetry. You could change some of the cells in it. There's another one. It could look like that. Oh no, not centered around that dot. It couldn't. It could look like that, but although that would bring another dot into play, but don't worry about that. All cells must be part of a galaxy. No galaxies overlap. Grey dots, I think we've only got one, mark renban galaxies, those with 2 or more cells whose digits form an unbroken consecutive sequence in any order. So the digits in a renban galaxy are consecutive, although they appear in any order. So it could be 2, 3, 4, 5. White dots are the centers of galaxies whose digits don't form a consecutive sequence. Digits may not repeat within a galaxy. There is one dark star, a single cell galaxy, that is not marked. So one single cell doesn't have its white dot. As per Galactic Map Standards, I hope these have been agreed by all planets and galaxies, all galaxies with at least 2 cells indicate their smallest digit with a diamond icon. All galaxies with at least 6 cells indicate their largest digit with a circle icon. The Galactic Census, I was wondering if that meant consensus, but it appears in the title, so I think Blobs has thought it through. The Galactic Census requires that all galaxies with at least 3 cells must report their star system count, which is actually just the sum of digits in their galaxy. So let's think of it as killer cages instead of galaxy. Every killer cage that appears in this puzzle, if it's 3 cells big, the total is given. That might be the 8. If it is 2 cells big, the total is not given. There is a single 1-cell galaxy without its total being given. If it's 2 cells big, that's almost all of them. The smallest digit is marked with a diamond. And if it's at least 6 cells big, the largest digit is marked with a circle. Okay, give it a try on that first link under the video. I don't know how this is going to go, but let's get cracking. So I am going to colour around all the dots. So there's a dot. All of those 4 cells must be in that galaxy. Let's make that yellow. Make that one red. I'm just doing the absolute centres at the moment, and then I will think about what they mean. I'm going to try and keep the colours separate so these galaxies aren't going to bump into each other in the same colour. But I'm sure I'll mess that up at some point because it's a little hard to predict where the galaxies go all the time. Let's have red there, orange and purple. I'm really just finding the dots and colouring around their centres at the moment to see what it's going to look like. Okay, well, that gives us a... Oh no, and there's this grey thing as well. Okay, I'm going to think about the grey thing first of all, because this is a renban galaxy. And with the number 21, I'm immediately thinking of 1, 2, 3, 4, 5, 6. The triangular number for 6 is 21. So those digits add up to 21. They could appear in this. And I was going to say, probably you can't get another run of consecutive digits adding up to the same number. And I've immediately thought of 6, 7, 8. Which definitely add up to 21. But that would be an odd number of digits. This must be an even size galaxy because the dot straddles 2 cells. So half of this galaxy will be on the left of that dot and half of it on the right. So it's definitely an even number of cells. Could you have a galaxy in 4 cells? No, I don't think you could. Well, I mean, you could just test them. 2, 3, 4, 5 is obviously not going to be enough. 3, 4, 5, 6 is not going to be enough. 4, 5, 6, 7 adds up to 22. You can't. So this is going to be a 6-cell galaxy. And if you look, it can't expand into there because the opposite symmetrical cell is there, which is already in a different galaxy. So this side's expansion has to be to there, and we can map that to the other side. Now we've picked up a diamond and a circle. And now we know that it must expand further to there and to the corner of the grid. And that is our 21 galaxy completed. Now, this cell, this is a 31 galaxy. 31 is more than 4 cells added together, because they might be 9876, but that only adds up to 30. To extend this galaxy at all, we can't go into that cell because it would be mirrored outside the grid. So we go into this one and that one, and now we've completed the 31 galaxy. This 25 can only, I mean, it's bordered by the perimeter, so it can't expand past column 1. But it must be more than 2 cells, so I'm going to add those cells in. Purple isn't, this violet rather, is now constrained and stuck. In fact, let me change the colour for clarity. That can't expand at all. This one can't expand at all because it's bounded by the perimeter. This 43 needs to expand a lot. In fact, 43 is going to be 8 cells big. The secret, that is the square root of the current year we are in, is that every row, column and box in a Sudoku adds up to the sum of 1 to 9, which is always 45. So if 1 to 9 add up to 45, a galaxy or cage with 43 in it is missing the number 2 only. So the other digit's number 8. There are 8 digits, just as there are 8 planets. In this case, 2 is Pluto. Now, where can this expand? It can't expand there, so it can't expand there. And it can't expand beyond this row going north, so it can't expand beyond this row going south. So I think it's going to have to take all of those cells in, and that is the 8-cell galaxy we're looking at for that 43. Now what's going on here? We haven't got... Oh, okay. Is it? I don't know. I don't know. I'm going to look down here first of all. That is complete. This one is complete. This has got a diamond in, and we were told that galaxies with 2 cells or more have their smallest digit marked with a diamond. Because of the 8 total, it can't be more than 3 cells. It must, because of the dot being within a cell, it must be an odd number. So this must be 3 cells. It must be those 3 cells. This is complete. That's complete. This cell can't go in that one, or that one. It's either the lone rogue galaxy on its own, or it's part of this. And indeed, this needs an extra cell or 2. This is a 33 galaxy. So it's got to expand from 4 cells, which can only add up to 30. And to the south and east, it can't go into any other cell than that one. So it must go into that, and now that is complete. This could be part of the 16, but doesn't have to be. Okay, this is a 40, and that's got to expand. Now again, we can take it just like the other one. To the south and west this time, there's only 1 cell it can go into. And it must go into something to the south or west to expand. So it expands to there. Now it could also expand to here. And it's a 40 galaxy, so it can't be done in 6 cells. 9, 8, 7, 6, 5, 4 only add up to 39. So it must expand. So we have completed that light blue galaxy now. This is in a galaxy with more than 1 cell because it's a diamond. And it's not in this one, which can't expand to there, and it's not in this one, so it's part of purple. Goes up to there at least. That's only 4 cells. We need 41. This is going to be another 8-cell galaxy because we know it's even and it must go above 7. So, or it must go above 6, and we know it's even. So we need 2 more cells. Now, it can't get any more to the south or north. To the west, it's going to take those 2. So to the east, it's going to be those 2 to make it symmetrical. And that's finished. Now we've got 30 here. That can't go into any more diamonds or circles. So its expansion is going to have to be straight. It could go further. This one is 13. And that can't be a single cell. that is going to expand into those two cells and be complete. This circle, I bet it's part of the right. What does 31 need? It needs more than 4 cells. And since it's going to be an even number, this is going to need 6 cells. Can't be 8. It's going to need 6 cells. It's got 2 so far. So to the west and north, those are the only 2 cells it can go in. So it's got to do both of those. And there we go. We've finished off yellow. Now I think we could decide that blue will complete like that, because otherwise these would both be single extras, and we're told there was only one. Let me just figure it out. Oh yeah, this blue. Yeah, I mean, I'm going to have to do this by what else can these 5 remaining cells be in. Only one of them can be a lone rogue galaxy. So this yellow can't expand, that green can't expand. Only these 2 colours of blue can expand, and they're both going to have to. I'm just checking. That is right. That's going to expand there, that's going to expand there, and then we've got one rogue single cell galaxy left over. And there we go. That is our galaxy map. Our galactic map. Now let's do some digits. So, in the biggest galaxies, the 8 cell galaxies, of which there were at least 3, the largest digit is marked and the smallest digit. The smallest digit is the diamond. So in the 41 galaxy, subtract it from 45, the only digit missing is a 4. The diamond is a 1, the circle is a 9. In the 43 galaxy, the only missing digit is a 2. The diamond is a 1, the circle is a 9. In the 40 galaxy, the only missing digit is a 5. The diamond is a 1, the circle is a 9. Now, in this 21 renban galaxy, we know this is 1, 2, 3, 4, 5, 6, so the diamond is a 1 and the circle is a 6. By Sudoku, these can't be 1. By killer rules, those can't be 1, and those can't be 1. There is a 1 in box 1. It's in the 16 galaxy, but it must be in the smallest cell, therefore, the diamond. 1 will normally be in a diamond. Yes, there's a 1 in this galaxy. It must be in the diamond, which marks the smallest cell. Ah, there's now not a 1 in this galaxy. And there is a 1 in one of these 2 cells. It must be in the diamond again. There's a 1 in this galaxy. It must be in the diamond. And that's the last one in the grid, unsurprisingly, on a diamond. So remaining diamonds are not 1s. Let's see how we get on with 9s. There's a 9 in one of those 2 cells, not surprisingly in a circle. There's a 9. It can't be in red. So the 9 in box 1 is in one of those 2. Red already has a 9 in. Now, there's no 9 in this 1, 2, 3, 4, 5, 6 galaxy. So one of these 3 in box 7 is a 9. And that goes with one of those 2. The 9 in row 9. Don't know. Nine's more difficult than 1s, is what I'm going to tell you. I guess one of those is very likely to be a 9. Right, let's look at the renban region. Everything else in this region is 2, 3, 4 or 5. Now these digits see all of those cells because they see these in the box and that one in the row. So they can't be anything from 1, 2, 3, 4, 5, 6. They must be selected from 7, 8 and 9. But only the low digits in those cages are marked. Okay, I might have to think about the remaining diamonds next. Not sure. Not really sure how to go about this. Those two digits add up to 12, these two to 7. It doesn't really let me fill anything in. There might be some general killer stuff to do, but I don't know the sum of every cage because I don't know the really small ones. And that's going to impact my ability to find anything useful. Sorry. None of these are a 2 because the red cage doesn't have a 2 in it, given it's 43 total. That is not a 2 because the diamond marks the smallest cell in this dark blue cage. So that can't be a 2 if this can't be a 1. So there is a 2 in the 16 cage because that's the only place left for a 2 in box 1. Yeah, maybe that's the sort of thing we're going to have to do. That's interesting. Oh, this can't be a 9 because it's not in a circle. So there's a 9 in one of those two cells. Oh yeah, 9 can never be in a... Right, there's no 9 there by Sudoku. If there's a 9 in the light blue, it's in the circle. There's no 9 in purple there because we've already had a 9 in purple. If there's a 9 in yellow, it's in a circle. So 9's in one of those two cells. Now 9 is not there. And 9 is in the galaxy. I knew 9 wasn't here. Sorry, 9 is in the lone rogue galaxy. It is a 9. I knew 9 wasn't here because it doesn't have a circle. In any 6-cell or more galaxy 9 appears in, it's in a circle. So we've got a 9 there and a 9 there. Now, 9 can't be here for the rule I've just laid out, so it is there. And then we've got a 9 in one of those two, and that hasn't quite resolved the 9 in one of those 3. Okay, but we've got a couple more 9s. Now, this galaxy doesn't have a 5 in. I'm not going to fully pencil mark yet. I mean, I'm not ruling out doing it at some point. Okay, come on, let's just think about this. I've got to come off the fence and start thinking about 30 and 31 here and what they're made up with. Oh, and 33, that's even bigger. And basically the question is, can it get away? Right, either the 31 cage here or the 39 cage. Sorry, either the 31 or the 33 cage fails to have a 9 in. Now, 8, 7, 6, 5, 4, and 3 add up to 11 times 3, 33. Oh, beautiful. Right. Why do I know that this cage has a 9 in, this green 33? Because if it didn't have a 9 in, the biggest digits you could put in it are 8, 7, 6, 5, 4, 3, which do add up to 33. However, they would be a renban cage and have a grey dot. And it doesn't have a grey dot, it has a white dot. So it must have a 9 in. So that is a 9, and that gives me a 9 there, and a 9 now in box 1. So there's a bunch of cells where 9 comes out. That's now a 7-8 pair. Now we've got 1, 9 and 2 in this cage. I'm going to call it a 1, 9, 2, 4 cage. Now this 13 cage doesn't have a 2 or a 4. These cells add up to 12 without being 9, 3 or 4, 8. They are 5, 7. Okay, so 33 is a good number and the minimum number that is actually useful. That doesn't, yes, now I can decide where the 9 is here by Sudoku instead. So that's the 9. It's in the 31 cage. This 30 cage does not have a 9 in. And it doesn't have a 1 in. So its digits are selected from 2, 3, 4, 5, 6, 7, 8. They add up to 45 minus 1 and 9, 35. And the one I have to take out to get to 30 is a 5. So these digits are 2, 3, 4, 6, 7, 8. The lowest is 2, the highest is 8. The others are 3, 4, 6, 7. And I know exactly where 7 goes because of this 5, 7 pair, which sees that cell and those. 7 goes there. The others are 3, 4, 6. And this one can't be a 4 because of the 2, 4 pair looking at it. So this is 3, 4, or 6. Right, I mean that was incredibly helpful when we got it going. Now the 33 cage doesn't have a 1 in it, because we've got all the 1s placed and there isn't one in it. Does it have to have a 2? If it didn't, we would be selecting from 3, 4, 5, 6, 7, 8, 9, which add up to 42. The one we would take out to get to 33 would be a 9. That's not possible because 9's in the cage. I think this has to have a 2 in it now. Let me just check that again. If we were doing for selecting without a 2 or a 1 from 3, 4, 5, 6, 7, 8, 9, they add up to 42. To take 1 digit out and leave 6 digits would mean taking the 9 out, which we can't do. So that is a 2. What we want to do is find a biggish cage which can't even have a 2 in. I don't think I've done that yet. But 2 is not in red. We worked that out earlier. So in box 2, 2 is in one of those cells. Down here, 2 is in one of these 3 cells. It's quite likely there. Okay, if this 31 cage didn't have a 2, it doesn't have a 1 or a 9. So in fact, actually we know what's in it. We're selecting again from 2, 3, 4, 5, 6, 7, 8, which are 7 digits, that add up to 35, and the digit missing is 4. So we are using 2, 3, 5, 6, 7, 8, and I am going to pencil mark the remaining 4 as 3, 5, 6, 7 now. We got the 2 and we got the 8. That 2 rules 2 out of those cells and says 2 is in one of these 2. And then 2 is in one of those 2. Now, this pair is either 3, 4 or 2, 5. Oh, what about the 33 cage? Well, you see, this isn't so clear because we do have a 9 in. We've got 2 and 9 in. Are there any digits that can't appear in this cage? I don't know. Oh, that can't be a 4 because this 34 cage doesn't have, sorry, this 41 cage doesn't have a 4. Right, 2, 4, 9, 1, 5, 7. These are from 3, 6, 8 in the top row. 1, 9, 7, 2, 8. These are from 3, 4, 5, 6. But 4 cannot be in purple, which doesn't have one. 2, 4, 1, 9. That can't be a 4 in the box, which already has a 4 in. Okay, let's think about 33 finally. So I'm selecting this time from everything from 2 to 9, which add up to 44. I'm taking out 2 digits that add up to 11. And they aren't 2, 9. So I'm either taking out 3, 8, 4, 7 or 5, 6. There's a lot of possibilities around that. I can't really do that cage. This one is 25 with a 9 and either 7 or 8 already in it. Oh, it's this one that doesn't have a 2 in. Oh, that can't be a 2. This is where 2 is in box 2. I don't know what I'm meant to be thinking about. I did notice 8 there and 8 there. Oh, I can place 8 in the bottom row now. Now, one of these 3 is an 8. This cage, I haven't really done the maths on that properly. I don't think it's all that helpful while this can be a 2. I'm selecting again from 2 to 9, which adds up to 44. This time I'm taking out digits which add up to 13 to get to 31. That's 2 digits, but I'm not taking out 9, 4 because 9's definitely in the cage. I'm either taking out 8, 5 or 6, 7. I'm not taking out 2, therefore. 2 is in the cage. Yeah, that's suddenly clear. Oh, I'm sorry I hadn't noticed that. If I was selecting from 3, 4, 5, 6, 7, 8, 9, which add up to 42, Why couldn't I be doing 3, 5, 6, 7, 8, 9? I don't know, it's because my maths has gone wrong. If I was selecting from 3 to 9, which add up to 42, I'd be taking out one cell worth 11. Okay, there's no such thing as one cell worth 11, so that is a 2. Now this is not a 2, this is a 2. This 8 cage has a 3 and a 4 in it. These are from 5, 6, 7, but to make the 16 cage work, they add up to 13, so that's a 6, 7 pair. 5 at the top, 7 there. This is lower than 8, is all I know. These are a 5, 6, 7 triple. That one can't be 7. So there is a 7 here in the 33 cage. Now there must be a 4 in it somewhere, because we're taking out a pair that sums to 11. Also, 5 or 6 must be in it. So now it's 8 and 3 that we're removing from this cage. And everything else is 4, 5, 6 or 7. Wow, well that was a useful deduction. That is 3, 5 or 6. One of these is a 4, because this purple cage is not allowed a 4 and nowhere else in the column can sustain one. So one of these is a 4, and that means this cell can't be a 4 because it sees both of them, one in a cage, one in a row. In fact, I've got a 6, 7 pair there, so that is 4 or 5, and that's not a 4. 1, 2, 9, 8 is in one of those two cells in the column. This is 3, 4, 5 or 6. Now, what was I missing from this cage? I was missing 2 digits that add up to 2 digits from 2 to 9 that add up to 44 minus 31 is 13. I'm not missing 8, I now know. So I've got 8 and 5 in. I'm missing 6 and 7. I've got 2, 3, 4, 5, 8, 9. Yeah, that is 31. 2, 3, 4, 5, 8, 9. We've got 2 and 9 placed. Everything else is from 3, 4, 5, 8. And I've abandoned any reserve about pencil marking now. 8's not there. Okay, I don't quite know what to do next. This one was 4, 5, 6, 7, and 7's in one of those cells. That's a 6, 7 pair. Okay. Oh, this cage. Look, I've got 3, 5, 6 triple. It's 4 that's missing, so that is now a 7, 8 pair. That's not 8. 8 is placed in yellow. There it is. That's now a 3, 4, 5. That's become a 6. That is the lower digit in the cage, which has a 7 or 8 there. Now, actually, can I just add up 25 here? Well, now I've got 2, 3, 4, and 5 to place, and that's the low digit in the cage. So how am I going to make this add up to 25? I've got either 17 there needing a 5 and 3, or 16 needing a 5 and 4. Yeah, we can forget 2. The only place for 2 in the column is in the corner. There is a 5 here. And not here. Now there's a 5 in one of those 3 cells, and they all see these 2, so there's no 5 there. That is a 3, 5, 6, 7 quad, so that's a 2, 4 pair. That's now 3 in the corner. Oh, Christmas tree. Oh, Christmas tree. And that's a 5. That's not a 5. We're motoring along here. It's also not a 7 in the row, so that's a 6. That's a 5. That's a 7. This is not a 6. In this row, that is 3 or 4. It has to be 4 in the box. That's 3. That's 4. No 7s there. That's a 3, 6 pair. This one is a 5. That one is a 7. This is going swimmingly suddenly. Now, 2, 4 are resolved there. 5, 4, 1, 9. 2 in this column is not allowed in red, so it's there. 6129. Now this cage doesn't have a 5 in. So the 5 in box 5 is in one of those two cells, and that's not a 5. That is a 3-6 pair, and that is a 5. That's not a 5, obviously. 2, 3, 6, that's a 4 by elimination. That's the 4 in row 2. That's the 8 in box 2. That is 3 or 6. It's in a cage that only has to miss 5. That's all right. 9, 4, 1, 5, 2. Okay. 3, 2, 9, 1, 4, 5. So 5 in box 1 is there for sure. That is 7 or 8. That can't be an 8 in the column. It's part of a 3-6 pair. This is going fine now. 4, 9, 5, 1, 2, 6. I'm looking down column 2. 3, 7 and 8. Now the one thing I know here is that this is the low digit in its little galaxy. So that is 3 or 7. This can't be a 5 because it is the low digit in its galaxy. So that is the 5. And these two are going to add up to 11 one way or another. 5 being there sorts out green. That gives us the 4 in yellow. This 5 sorts out the rest of yellow. Now I can do box 3. Now I can do purple and blue galaxies to an extent. Look, I've got a 3, 6, 7 triple in that row. This is 8. Therefore that's not 8. Therefore the 8 in column 2 is here. That's a 7. To add up this galaxy tells me this is a 4, I think. 21 and 4 is 25. That's an 8, that's a 7, that's a 7, that's an 8. We are flying along here, identifying galaxies all over the place. Right, that's very few pencil marks left. That 3-6 pair in blue makes that a 7. And then that feeds back into the rest of the galaxies and sorts them all out. And there we go. That is Galactic Census 2. I didn't get a tick. Oh, I've still got 2 digits to do. Oh, okay, I get a tick there. Half an hour to do a galaxies puzzle. That is brilliant ever. That puzzle is rated at 98%. And when Blob sent it to us a while ago, it was at 100%. And I'm not surprised. It's a very clever puzzle. You know, not too difficult. Decent introduction to Galaxy Sudoku, as long as you keep all the rules in your head and moving along. So, very happy New Year to you. And if you like Blob's puzzles, and how can you not after that, check out The Hobbit on our Patreon. Do join us on Patreon. Make it a great New Year's resolution to yourself, and it'll pay dividends. Thank you for watching. Hope to see you again soon on the channel. Bye for now.